Homogeneous and non-homogeneous polynomials. When a multivariable polynomial has the same degree in all its terms, it is called homogeneous. For example, the figure on screen is a homogeneous polynomial because all its terms are of the fourth degree. On the other hand, the polynomial now shown on screen is not homogeneous, as its last term has not got the same degree as the rest of the terms. It is a zero-degree monomial, while all the rest of the terms are fourth-degree monomials. Hence, knowing the degree of a polynomial has another advantage, as this helps in finding whether the given polynomial expression is homogeneous or not. Example: which of the following polynomials is homogeneous? Solution: A. This is a homogeneous polynomial, as all its component terms, 5x, 2y and 18z, are of the first degree, despite having different variables. B. This is a homogeneous polynomial too, as all its component terms, now shown on screen for reference, and minus C9, are of the ninth degree. 5 plus 1 plus 3 equals 1 plus 6 plus 2 equals 9, despite the fact that the power of each individual variable is different. C. This is not a homogeneous polynomial, as not all its component terms have the same degree. Thus, the first term, 2 meters cubed, is of the third degree. The second term, minus m squared n, is also of the third degree. 2 plus 1 equals 3. Yet, the third term, minus mn squared, is still of the third degree. 1 plus 2 equals 3. However, the fourth term, minus 4mn, is of the second degree. 1 plus 1 equals 2. Hence, the given polynomial is not homogeneous. That is all for lesson 11.1.8, and the final lesson of tutorial 11.1. Our next tutorial is 11.2, Operations with Polynomials, starting with the first lesson, 11.2.1, the like and unlike terms in polynomials. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.iCalculator.info.